Okay, so for number 2, we want to give two parametric equations that generate a circle centered at the origin with radius 6. So in our normal Cartesian plane, this circle here would be described by the equation x squared plus y squared is equal to 6 squared because the radius is 6. But now we want to express both x and y as an output of another parameter t. So t is going to be our input and x and y are both outputs. And the way that this works is we're going to think of it like a triangle. So where the input t is going to be our angle. So you plug in an input t and it's going to give you two outputs. It's going to give you the output y, which is your vertical height, and it's going to give you the output x, which is going to be your horizontal length, right? So this idea that for any angle in this circle, you just give t as your input, and it will spit out both the y, which is the vertical height, and the x, which is the horizontal length. So how do we express y and x in terms of t? The hypotenuse here is 6, because that's our radius. And so we just have to remember our trigonometry, our SOHCAHTOA. So which means that our sine is opposite over hypotenuse, right? And so this here is y and this is x. So what it means here is that sine of t, remember sine is opposite over hypotenuse, is going to be y over 6, opposite over hypotenuse, and cosine of t, cosine is adjacent over hypotenuse, is going to be x, which is the adjacent to the angle t, over 6. So multiplying both sides by 6, we have that 6 sine t is equal to y, and 6 cosine t is equal to x. So that's our first set of parametric equations, where t is our input, and we can see that it gives us both x and y as an output. So that's the first one. However, we could also do it the other way around, right? We could maybe consider that, so we could consider another triangle, but instead of taking t as we normally do here, we're going to take t as going from up here. All right, so it's the angle that it makes, not with the horizontal, but with the vertical. So, for example, you could think of, like if say you're at this angle. You're at this angle. Your reference angle, this would be t, normally, right? However, now we're going to make our reference angle be the vertical angle. That's going to be our t. So that's the second possibility. And if we can consider that t is the angle that it makes with the vertical and not the horizontal, and this is still 6, so now let me redraw this. So that's 6, and this is t, right? Well, now the opposite is going to be x, and the adjacent is going to be y. So therefore, it means that y is the adjacent. So y is going to be 6 cosine of t. And x is the opposite. So x is going to be 6 sine of t. So it may seem a little strange, but this works, right? Because any value that you give for t as an input, it's going to spit out an x and a y that are in horizontal and vertical components. So you can really span this whole circle, right? You could say for whatever angle that you want. So maybe you want to express being at this angle here. So we would make this triangle. We would make this triangle here, and we would do, this here would be our t, because our t, would be here, and this here would be our t, because our t is making an angle with the vertical, not with the horizontal, right? And so that is it for this problem. We were able to find two equations. This one, the first one here, where y is equal to 6 sine of t and x is equal to 6 cosine of t, or we could take the other reference angle with the vertical and say that y is 6 cosine of t and x is equal to 6 sine of t. Either of these will span the entire circle for all values that you input of t, and they will treat x and y as outputs. So that is it for problem number 2.